Good afternoon, class. Here's practice test number 2 for statistics, module 2 covering chapters 4 and 5. Here's chapter 4, probability. And again, just reminding you of the pledge before starting each exam. I pledge on my honor that I will neither give nor receive unauthorized assistance during this or any other exam. Unauthorized actions include, but are not limited to, the use of notes, text, search engines, PowerPoints, AI, or any other resources not explicitly allowed. You may use formula sheet, tables, and a graphing calculator. So here's chapter 4, probability. Definition: a simple event and a sample space. We want to define those. A simple event is an outcome or an event that cannot be further broken down into simpler components. A sample space is the set of all possible outcomes or simple events of a probability experiment. If two events are mutually exclusive, also known as disjoint, the probability that both will occur is 0. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, disjoint events do not overlap. Probability of A and B, this is one way to write it. Probability of A and B, or probability of A intersection B, all mean the same thing, intersection of events. And A intersection B is the intersection of events, and the probability is 0. The probability of an event is always between 0 and 1. Probability of A is N of A over N of S is the probability of event A, and P of A is between 0 and 1. Can it be equal to 0? Yes. Can it be negative? No. Can it be equal to 1? Yes. Larger than 1? No. The sum of probabilities of all final outcomes of an experiment is always 1. The sum of the probabilities of all the outcomes in the sample space is 1. Summation of P sub I equals 1 always. So just to understand how this thing works, let's look at an experiment involving rolling a die. It's a regular die or a common die, has 6 sides. 1, 2, 3, 4, 5, 6. Those are the numbers. Sample space. The common die has 6 faces. We usually call the faces 1, 2, 3, 4, 5, 6. So that's the sample space. An example of a simple event: any individual number such as 1, 5, etc. A compound event: any event having more than one outcome, such as odd numbers 1, 3, 5, even numbers 2, 4, 6. So those are considered compound events. We are interested in finding the following, so answer the following. The number of combinations of n items, selected n at a time, the number of permutations of n items, selected 0 at a time. So first, reminding everybody, n factorial means n times n minus 1 times n minus 2 times all the way to number 1. N is a whole number. What is the counting method in probability? So before we answer those questions, let's get to some important information. The counting method is a mathematical technique used in combinatorics and probability to count the number of possible outcomes in a situation, especially when listing them all would be inefficient or impossible. The fundamental counting principle indicates if one event can occur in m ways and another one in n ways, both together can occur in m by n ways. Example, you have 4 shared colors. 3 pants, 4 times 3, you have 12 outfits. Permutation, order matters. It is an arrangement of objects in a specific order. Order matters. Example, the letter arrangements of ABC, ACB, BAC, BCA, CAB, and CBA are all counted separately as 6 different permutations. When n different items are available and r of them are selected without replacement. Arrangements where order is important, formula NPR. This is one way to write it. By the way, NPR or PNR. Those are the two ways that we write them. N factorial over n minus r factorial. So, for example, how many ways to assign first, second, and third place from 5 runners? Obviously, order becomes important. However, when it comes to combination, order doesn't matter. Combination is grouping of objects, order doesn't matter. For example, if you go back just to this one, all of them really contain A, B, C. That's all that matters. Order is not important. The formula NCR is n factorial over r factorial times n minus r factorial. Notation, we have NCR like this, or NCR like this, or even a parenthesis n comma r, just in case if you come across and all of them mean the same thing. So as we mentioned, formula is combination of n choose r n factorial over r factorial times n minus r factorial. Example, choosing 3 cards from a deck of 5. Order is not important. As it was mentioned, of course, n factorial is n times n minus 1 times n minus 2, so on and so forth. So going back to these questions now, let me erase my work. So combination of n choose r, this is the formula. By the way, it's the same as permutation, n choose r divided by r factorial. So now we are going, so in this case, because we are selecting n from n, r will become n. This is n factorial, this is n factorial, n minus n is 0, 0 factorial is 1. And these two simply give us 1. Permutation of 0. So this is the formula. And replace the r with 0. And in general, NPR, one way to write it is n factorial over n minus r factorial, or n times n minus 1 times n minus 2, all the way to n minus r plus 1. There are items there. If we go with this formula, the numerator is n factorial. The denominator n minus 0, that means also n factorial, and therefore the answer is again 1. Just wanted you to see how this thing works, okay? A pizza parlor offers 10 different toppings. How many 4-topping pizzas? Different with different toppings, of course, or possible. We are going to use combination because order is not important. Your first pick, whatever it might be, or the second or third or fourth, makes no difference. So we're going to follow this formula. And into this formula, n is 10, r is 4. That's what we put in. This is n factorial, it's 4 factorial, it's 6 factorial. You can put it into a calculator, come up with the answer. Simplification would be that you notice 6 factorial at the bottom, so you can keep that, and this is 10, 9, 8, 7, and then stop at 6 factorial, drop the 6 factorial, and take it from there. So it is possible to do that. So I'm going to show you quickly, but so the bottom 6 factorial, because of that, you're going to write this one as 10, 9, 8, 7, and 6 factorial. Now 4 factorial is 4, 3, 2, 1. Again, if you were to do it by hand, you don't have to. These two cancel each other. 4 times 2 is 8. And then 9 and 3, they give you 3. So 10 times 3 times 7 is 210. So it's fairly easy to do it by hand, but you can use calculator. How many 6-letter code words can be made from 26 letters of the alphabet if no letter can be used more than once in the code word? Obviously, order is important because we're dealing with coding, and therefore we're going to use the permutation, where n is 26, and we're going to choose R 6 items. So this really means 26 times 25, 24, 23, 22, 21. That's how you would look at it. Or you change this to 20 factorial, and the simplification that I showed you, you drop the 20 factorial and the top remains as the numbers that you see. You put it into a calculator, you get a huge number, 165,765,600. It's a fairly large number, as you can see. Suppose a bakery has a selection of 20 different cupcakes, 10 different donuts, and 15 different muffins. If you're to select a tasty treat, how many different choices do you have? So remember, you are going to choose one. So just add them up. 45, because we just add them up, 20 and 10 and 15. Because we have to choose from either a cupcake or donut or muffin, notice the or statement, we have 20 plus 10 plus 15, 45. We have one choice. That's really the ideal. One choice from either or. One choice. If you're to select one of each tasty treat, how many different orders can you choose from? Now it's a lot more. It's 3,000. Why is that? We're going to choose one from here, one from here, and one from here. So this gives us 20 choices. This gives us 10 choices. This gives us 15, and therefore we're going to multiply. The fundamental counting principle, we can choose treats from a selection of cupcakes and donuts and muffins. Notice the and statement, 20 times 10 times 15. We have 3,000 ordering options. So I hope everybody can distinguish between the two. I'm going to answer the following. A quiz consists of 3 true-false questions. How many possible answer keys are there? Write out the sample space and tree diagram. So the formula is N of S is number of outcomes per stage, and the power is number of stages. I hope you see we have 3 questions. Those are different stages. And each one has 2 choices, true or false. So the number of outcomes per question per stage is 2. There are 3 questions or 3 stages, so 2 cubed, which means 8. Now look at the first one. Stage 1, question 1 is true, false. Now the second one, true, false here, and the third one, each one gets a true, false. So here's the second one, TF. So if we had only 2, we would have TTTF, FTFF. There would be 4 outcomes. However, we have one more, so TF and so on. If you look at the top branch, means TTT. This one would be TTF, and so on and so forth. So if you go to the bottom, is F, F, T, F, F, F. That is our sample space. We have total of 8 possibilities. The sample space for tossing 5 coins consists of how many outcomes? Write out the sample space. Okay. So we said N of S is the number of outcomes per stage. So coins or like true false coins have two choices, heads and tails, two outcomes. How many coins? 5, then 2 to the power of 5. That means 32 outcomes. So it's important to understand what's going on here. Okay. So we have 32 outcomes. The tree diagram for 5 coins. Just let me just draw these lines. Okay, just look at the first one. Never mind the second. The first one we have H and T. And by the way, to be consistent, if H is the top branch and T is the bottom branch, keep up with that. So if you look at just the second stage, so H, then we are here for H, we have HT, for T, we have HT. So just here means HH, HT. This one is CH, TT. So if you stop at those two, just for the sake of argument. However, we're going to continue because we have 5 coins. So here's the first stage or the first coin, second stage, second coin, third stage, fourth, fifth stage. So if you look at the very top one, we have H, 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 H. The second one would be H, 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 T. The very last one, T, 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 H, T, 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 T. And that gives us the 32 outcomes. And I hope everybody's clear on that. It's very straightforward, everybody. A random sample of 100 people was asked if they were for or against the tax increase on rich people. Of 60 males, 45 were in favor, and of all females, 22 were in favor. Write the contingency table and answer the following question. If one person is selected at random, find the probability that this person favors the tax increase on rich people. So here's the contingency table. Okay, we want to look at the contingency table. We have total of 100 people. We have male, female, those who are for and those who are against the tax increase. So a contingency table looks something like that. So male, we're going to represent it with M, female with F. So this is male, this is female. For tax increase, we're going to represent it T, against it with A. So that's just to make it nice and easy. So the very first number is 100. This is the entire population. So we have 100 here. Then it says, they were asked if they were for or against it, and of 60 males. So here's M. The entire population of males is 60. So 60 goes here. 45 were in favor. So for tax increase, so 45 goes here. Of all females, so females would be the second row. I mean, if you consider this one, the first row would be the third row, but the female row, okay? 22 were in favor. So how many are in favor? 22. 22 goes here. Now we can write the contingency table. How do we write that? First and foremost, if this is 100, that means this must be 40, everybody, right? Because 40 and 60, they add up to 100. So now if you look at these two, 22 plus what number is 40? Must be 18. All right. Now for this one, if we have 45 here, we must have 15 here. So if you add these two, you get 33. And you can add these two, you get 67. And to check, you add these two, you must get 100. So this is how you come up with the rest of it. I'm going to erase my work. So first we filled up the continuous table. Now this person favors the tax increase. Probability of T is N of T over N of S. I like to start with the denominator or the sample size always. That is 100. And how many in the T column? 45 plus 22 or simply 67. And you always keep it as a fraction exact answer. Of course, this happened to be 0.67. So it's not going to be a problem. But if they ask for decimal percentage, make sure you have enough decimals. Normally, many, many, many. That's why I'm not going to change the fraction in general. In this case, it makes no difference. All right, this person is a female. So P of F is N of F over N of S. N of S, again, the entire population is 100. How many females? So we look for the F row. We have a total of 40. 22 plus 18. And the answer is 40 over 100. Now, every fraction must be put in its lowest term, 2 over 5 or 0.4. Those are exact answers. This person opposes the tax increase on rich people, given that the person is a female. Or another way of writing it, if this person is a female, she opposes the tax increase. This is known as conditional probability. Conditional probability has a specific formula. Probability of A given B. This is how we read it. Probability of A, this line segment is read given B, is probability of A intersection B over P of B. Whereas probability of B given A is probability of A intersection B over P of A. So in this case, we are dealing with probability of A. Okay, this person opposes a tax increase. That means probability of A, given that the person is a female, given F. So A given F, which is P of A intersection F over P of F. Or you can change it to N because both of these, or whatever the answer is, divided by the entire population of 100, they cancel each other. So if I'm answering a conditional probability, I always start with the denominator. And what you should notice, the population, the sample space was 100. When it's a conditional probability, the sample space shrinks to what you see after the line segment. After the line segment comes the group called females, and therefore 40 is the denominator. So the sample space of 100, now it's smaller. Now, out of those total 40 females, how many are against the tax increase? And N of A intersection F. Let me just do this so it makes it easy to see. So if you look at this group and this group, I hope you see that 18 is in common for both. Therefore, 18 over 40, you simplify it to 9 over 20 over 0.45. This person is a male, so probability of M, given that he favors the tax increase, so favor T, so probability of M given T, we're going to use probability of M intersection T over probability of T. So let me erase my work again. And again, first and foremost, N of T, so the probability becomes just N. So T, and instead of 100, the sample space is smaller now, it's 67. So the denominator is 67. Out of those 67, 45 are males and 22 are females. And what do we want? Male. Therefore, we go with 45 over. So if we go with the probability, it would be 45 over 165, 7 over 100. That's why you go to N, and it's 45 over 67. This is what I mean. This one, you have to put a lot of decimals in case they ask you. You just want to follow the instruction and put enough decimals. I'm going to continue with the same question. Now, this person is a female and favors the tax increase. The formula probability of F intersection T is N of F intersection T over N of S. In other words, that 100 hasn't changed. Now, the two groups that we are looking at, females, this group, okay, in other words, this row, and then T, this row. And I hope you see that this group and this group, this number is in common, 22 over 100, and it changes to 11 over 50 or 0.22. All right, again, I'm going to erase my work. This person opposes the tax increase on rich people or is a female. Here's the or statement in probability. Probability of A or B is probability of A or probability of A union B. That's how we write it. P of A plus P of B minus P of A intersection B, because this repeats in each case. So for this case, we're going to write probability of A union F. And we're going to write N of A plus N of F minus N of A intersection F over N of S. So we can put them into three different fractions or one weak fractions. So what is N of A? Let's find the A group. This is 33. N of F, the F group is 40. And we're going to subtract the 18. So let me show you why we do that. So if we look at the A group, is this one. Females is this one. So what we are looking at, this number 18 belongs to both groups. So what happens? It repeats. That's why you have to take it out once. So we get 33 plus 40 minus 18 over 100. And we get 0.55. So I hope everybody is clear as to why we do that. It's being repeated. Are the events females and opposes tax increase on rich people independent? Explain. So let's go over the concept. First, independency. We know the conditional probability, right? Probability of A intersection, A given B is probability of A intersection B over P of B. And probability of B given A is probability of A intersection B over P of A. And if I do the cross section, I can get probability of A intersection B. And I get probability of A intersection B is probability of B times probability of A given B or probability of A times probability of B given A. So that's the way you calculate the intersection. Now, here's the important definition. Independent events. The occurrence of one event does not change the probability of the other event. This statement is very hard to understand, but it becomes clear when we look at the formula mathematically. It means probability of A intersection B is probability of A, probability of B given A is probability of B, meaning conditional probability just changes to a basic marginal probability. Therefore, if they are independent, if you look at this formula, probability of A intersection B becomes probability of one times the other, probability of A times probability of B. So we are going to look at a conditional probability that has these two events involved. So events females and opposes the tax increase on rich people are dependent because the occurrence of one of the events does affect the other event. So how do we know that? This really is really vague. So having said that, we are going to look at the proof. Probability of A given F, okay? Remember, what comes after, that becomes the sample space. So F, let me erase my work first so it becomes clear. So the F, this row, has a total size of 40, and out of those, how many are A's? In other words, against it, 18 over 40. Whereas probability of A, okay, we want to see if they are equal. The denominator is the entire group, which is 100, and probability of A is 33 over 100. Are they equal? No, because they are not. Therefore, it makes them dependent. There's a second method to check it, and I'm going to write it and you check it on your own. You can check this by looking at probability of F given A. And I'm going to leave it for you to show you that it's not equal to probability of F. Okay, it's very simple to have it done. Are they mutually exclusive? No. Let me erase my work. They are not mutually exclusive because a person can be both female and opposes tax increase on rich people. Again, it's okay, but better look at it from a point of view of a math and numbers. Probability of A intersection F. The denominator is 100, and what is in common? The A group and the F group, 18 is in common. So 18 over 100. Is that equal to 0? No, therefore, it shows that they are not mutually exclusive. Okay, one asks the following, find the probability of getting the outcome of tails and 2 when a coin is tossed. As mentioned, independent events, probability of A intersection B is probability of A times probability of B. And the two events are completely independent because the occurrence of one has got nothing to do with the other one, tails versus, a number, any number, by the way. Tails has the probability of one half or 50%. There are 6 outcomes, and this is one number, so 1 out of 6, and it's 1 out of 2. A classic counting probability is to determine the number of different ways that the ladder of personnel can be arranged to find the number. So here's what we call permutation rule, distinguishable permutation. When some items are identical to others, the number of different permutations or order counts when n items are available and all n of them are selected without replacement. But some of the items are identical to others is found as follows. N1 are alike, N2 are alike, and N sub k are alike. The formula is n factorial over n1 factorial times n2 factorial times n sub k factorial. So we write down how many P's, E's, R's, and so forth. So clearly there are 9 letters to begin with. Okay. P, we have one of them. E, we have two of them, one here, one here. Or we have one of them and the rest of them all the way to the end. Okay. So now we are going to write the formula n factorial divided by n1 factorial times n2 factorial times n sub k factorial. And so you just plug in. That's all you have to do. 9 factorial over 1 factorial times 2 factorial times 1 factorial, 1, 1, 1, 2, 1, and it ends up giving us the following answer. So I hope everybody is clear that it's really not that big of a deal, okay? Just that's the methodology, and that's how we arrive at the answer. All right, we are going to move on, everyone. All right, so what's happening in this case? A box consists of 14 red and 36 blue markers. If we select 3 different markers randomly, what is the probability that they are all red with replacement? And that's the key, with replacement. So what happens here? Basically, the probability of 1 red would be 14 out of 36, and then 3 of them would be 14 out of 36 to the 3rd power because it repeats and it's with replacement. So probability of R, R stands for it here, is N of R over N of S. So 14 over 14 plus 36. And 14 over 50 simplifies to 7 over 25 or 0.20. If you want three of them, they are independent. One way to write it is P of R1 intersection R2 intersection R3 means P of R1 times P of R2 times P of R3 because they're independent as a result of with replacement. Each one has the same value, 0.28, raise it to the power of 3. You can write it as a fraction, as a decimal, and that's the answer. Now, what about this one? We are going to repeat the question, but here's the difference. What is the probability of that they are all red without replacement? Draw a tree diagram and label each branch. By the way, this is really a more proper way. If they don't mention with or without replacement, it means without replacement. So it's important to understand what happens here. So we're going to write probability of 3 red is probability of R1 times probability of R2 given R1 times probability of R3 given R1 intersection R2. So we're going to stick with the very first one is obviously the same answer. 14 over 50. By that, of course, we know it simplifies to 7 over 25, but I want to go with the same so you see what happens. Now, the second one here, R2 given R1. First and foremost, there were total of 50. We no longer have 50. How many is left? 49. Why 49? 1 is gone. So the denominator is 49. What about the numerator? Because we want red and 1 red has been picked, now it goes down by 1 also, 13 over 49. Now the last one, the same thing. The denominator from 50 to 49 to 48 because 1 is gone. And the numerator from 14 to 13 to 12 because 1 red is gone. And that is the answer, and you come up with the answer, putting it into a calculator, 13 over 700 or 0.0186. 0.0186. And we're done. Here's the other method. The second method is to write probability of R3 is combination of 14. From 14, choose 3. And over the entire sample space would be combination of 50, choose 3. Now, I'd rather write it in this format. Understand why this is not given, because we want 0 from 36, and in general, CN0 is 1, so this is 1. So that's why if you don't write it, it's okay. However, what is the importance of writing it? What if instead of saying 3 red, I want 2 red, and let's say 1 blue. So this number 3 changes to 2, number 0 changes to 1. That's why it's really helpful to have that, everybody. Okay. Let me erase my work, and I want to show you. This is very important. The tree diagram. Just look at the very first one. 14 out of 50 is red, 36 out of 50 is red, and you're done. When you go to the second stage, the denominator for all of them is 49. For this one, 1 red is gone, so it goes to 13. But for this one, all blue, 36 is left. We go to the blue branch, all red is left, 14. Blue, 36 goes down to 35. And the third stage, 14 goes to 13, goes 12. The denominator is all 48. And I hope you can figure out the rest on your own. It's really not that big of a deal. All right. If the probability of winning the race is 5 over 12, what is the probability of losing? We are going to go with the complementary event. Given P of W, W stands for winning, is 5 over 12, then probability of A naught, the complementary event, complement to A is 1 minus P of A, and therefore P of losing is 1 minus P of W. 1 minus 5 over 12 is the answer, which gives us 7 over 2. What are odds against winning? And sometimes people mix up the odds and probability. Those are two different things by definition. The actual odds against event A, O A naught is P of A naught over P of A, expressed as a form of A to B, A and B are integers. So O of W naught or O of losing is P of L over P of W, which means P of losing, probability of losing is 7 over 12, winning is 5 over 12, and it's a complex fraction. The 12s cancel each other. 7 to 5 is the final answer. Now, there is a difference between odds and probability. When the probability is extremely small, then the two numbers become very close, and that's why sometimes there is a mix-up. If the payoff odds is listed as 6 to 1, how much profit do you make if you bet $10 and you win? Well, the payoff odds against event A is defined as net profit divided by amount of bet. So payoff odds is net profit divided by amount of bet. So just look at this one. Cross product means net profit is the product of these two. The payoff odds and the amount of bet, 6 times 10 is $60. Very straightforward, everybody. When two different people are randomly selected from those in your class, find the indicated probability. Assume birthdays occur on the same day of the week with equal frequencies. Probability that two people are born on the same day of the week. Probability that two people are both born on Monday. I hope you see the difference between the two. This means any day is fine. This means specifically we chose a day. So a probability of some person being born on a specific day of the week is 1 out of 7. But if you want two of them, one of them really doesn't matter what day. So no particular day is specified. The first person can be born on any day. The second person has the probability of 1 over 7. So the final answer is really 1 over 7 because the first one has 7 choices. Any day is fine. But the second one, there is no choice for it. 1 out of 7 is 1 over 7. Whereas this one, each one has to be 1 over 7. So probability of the first person born on Monday, the same as the second, the third, the fourth, doesn't matter, is 1 over 7. And therefore 1 over 7 times 1 over 7 or 1 over 49. And that's the idea that is important to understand. How many different auto license plates are possible if the plate has 2 letters followed by 4 numbers? So we are looking at how many 1, 2, 3, 4, 5, 6 spots, 2 and 4. So we start with 2 letters and then 4 numbers, and there is no other explanation. That means where? How many letters? 26. Any restrictions? No. How many numbers? 0 to 9. There are 10 numbers. So 26 squared times 10 to the power of 4. And again, this explains the reasoning behind it, and that's important to see. 3 letters, no repeat, followed by 3 numbers. So again, we have the same 6 spots, and we can't repeat the letters. 26, 25, 24. And then 3 numbers, and we have 10, and there's no restriction for the next one. So 26 times 25 times 24 times 10 cubed. 4 letters, repetition allowed, followed by 2 numbers. Again, we have the same 6 spots. Okay, so the letters 26, and we can continue with that. How many of them? There are 4 of them. And then 2 numbers, 10, but there is no repeat, so it must be 9 here. 26 to the power 4 times 10 times 9. I'm assuming everybody can clearly and easily evaluate those. I just want to give you the reasoning behind that. So 4 places. Each character is either a letter or a number, alphanumeric. So we have 4 spots. And how many letters? 26. How many digits? 10. So how many alphanumerics? 36. Therefore, each one has the spot with the number 36. The answer is 36 to the power of 4. So pretty straightforward, everybody. In a first grade school class, there are 10 girls and 8 boys. In how many ways can the students finish first, second, and third in a foot race? Assume no ties. Obviously, we are dealing with a permutation. Order is important. And by the way, I'm giving you information how to use the TI calculator to find the factorial, to find NPR, to find NCR. You start with the value and then press math and PRB and you find factorial and so forth. So having said that, order is important because we are looking at what? First, second, and third place. This is the reason. And how many spots, how many students do we have? We have total of 18. And how many spots, first, second, third? There are 3 of them. So permutation of NR 18, 3. And we go with the formula, or 18 times 17 times 16. If you put it into a calculator, it works the same way, 4,896. The girls finish first, second, and second in geography contest. First and foremost, we are just dealing with 10. So again, order is important, but this time we have only 10, and we want to, so n is 10. N is 10. And we want to choose how many? First and second, we want to choose 2. So P and R, P of 10, 2, 10 times 2, 9, and the answer is 90. 3 boys be selected for launch duty. So we are dealing with only n being 8, and we want 3 of them, and order is not important. It's the combination of 8, choose 3. 8 factor over 3 factor times 5 factor is 56. It's very straightforward. Now we want 6 students be selected for a hockey team. So we have how many students? Total of 18. And how many do we want? 6, and order is not important. Combination of 18, choose 6. 18 factorial over 6 factorial times 12 factorial. And you can put it into a calculator. First you put 18, then NCR 6, and it gives you the answer, and you're done. 5 students be selected, 3 boys specifically and 2 girls. So from boys, we're going to choose 3. From girls, we're going to choose 2. Obviously, this is a combination. Order is not important, but let's stick with each case. So for boys, combination of 8, choose 3. For girls, combination of 10, choose 2, and multiply the 2. Okay. 8, 3, 10, 2, and you go through the process. 8 factor over 3 factor times 5 factor. This 10 factor over 2 factor times 8 factorial. These two cancel each other. You work it out if you want. And it's 2,520. And obviously, you can cross them out. And then 5 factor is the largest one. You can write this as 10, 9, 8. If you're doing it by the hand, 6, 5 factorial. This one cancels out this one. Then this is 3 times 2, and this is just 2. 2 factors 2, and then you do the math, you end up with the answer. Now, 4 girls be selected for a field trip. So obviously, we are dealing with n being 10. There's nothing else mentioned, so order must not be important. It's a combination. And C n R or C 10 4. 10 factor over 4 factor times 6 factorial gives you 210. Very straightforward, everybody. In a lottery game, a player picks 5 numbers from 1 to 48. If 4 of the 5 numbers match those drawn, the player wins second prize. What is the probability of winning this prize? So it's important to understand. We're going to go with the probability, which says the probability of winning is n of winning over n of s. I like to start with n of s, the sample space, always. So we are picking 5 numbers from 1 to 48. So n of s, n of pick 5 number from 48 numbers. So it's a combination of 48, pick 5. There is nothing specific about it. It's a combination. Order is not important. 48 factorial over 5 factorial times 48 minus 5 factorial. That is n of s. But what is n of winning? We want 4 out of 5 numbers. That means n of 4 correct and 1 incorrect. And order is not important. We just want 4 of them to be correct. Now, 4 of them to be correct, we have 5 numbers, okay? 4 of the 5, so combination of 5, choose 4. And then the rest of them, okay, 48 minus 5 is 43. From what is left, 48 minus 5, 43, we want to choose 1. So please understand this one is the 48 minus 5. From the 5, we choose 4 correct ones. From the rest, 48 minus 5 is 43. We want to pick 1. And so it's the case. By the way, this is 5, choose 4. This is 5. This is 43. And then you do the simplification. You come up with the answer. So pretty straightforward. A poker hand consisting of 5 cards is dealt from a standard deck of 52 cards. Find the probability that the hand contains exactly 2 face cards. Okay, so first and foremost, the probability of 2 face cards is n of 2 face over n of s. Okay, and this is the card with faces Jack, Queen, and King. A standard deck contains 52 cards, 4 suits, hearts, diamonds, clubs, and spades, 13 cards per suit, totaling 52 cards overall. Face cards, any king, queen, or jack of a suit. So having said that, first n of s. N of pick 5 cards from 52. Pick 5 from 52. So combination of 52, choose 5, which is 52 factorial over 5 factorial times 52 minus 5 factorial. That's very straightforward. Now, 2 faces. Okay, we have 2 face, and then the rest of them, that means out of 5, 3 non-face. That's the first thing to understand. N of 2 face means n of 2 face cards and 3 non-face cards. So how many face cards do we have? We have 1, 2, 3 per suit, and there are 4 times that, we have 12 of them. The rest is 40. So if the total is 52, 12 face cards, none is 40. So from the face cards, we want to choose 2. So 2 from here, 3 from here. It's a combination of 12, choose 2 times combination of 40, choose 3. That's the numerator. And now you put it into a calculator. The rest is history. This is the justification as to what you need to do. This is 66, is 9880. You simplify the final answer to 209 over 833. You always keep it as an exact answer. Exact answer. So even if you can't do the simplification, you put in the calculator, it gives you 10 decimals. You keep all decimals, unless they ask you to round it, and you do it accordingly. A factory receives a shipment of 16 sprockets, and the vendor who sold the item knows 7 of them are defective. Before the receiving foreman accepts the delivery, he samples the shipment, and if too many of the sprockets in the sample are defective, he will refuse the shipment. If a sample of 7 sprockets is selected, find the probability that all in the sample are defective. Obviously, probability of all defective is n of all defective over n of s. And as I mentioned, I like to start with my sample space. I want to know what I'm dealing with. And in this case, the sample space, we have 16, okay? And we are choosing 7. So combination of 16, choose 7, it's the sample space. Now, all defective, that means combination of the 7 that are defective, 7, choose 7. The rest of it, that means 16 minus 7, 9, gives us only 0. So n of all defectives is C7, 7. This is 7 from 7. And this one, if you don't write it, it's fine. This is 1, but it helps if the numbers are different. For example, 5 defects, 2 non-defects. So then this would be 5, this would be 2. So this is what matters. The rest is elementary algebra. Just, put it into a calculator. Each one of this is 1, by the way. This is 1. This is 1. So you put the denominator into a calculator, 14. 11,440. That is your denominator. The numerator is 1. That's an exact answer. And you're done. Here's the second method. There are 7 spots. So if a sample of 7 spots, find the probability that all in the sample are defective. And by the way, this is obviously without replacement. The very first spot would be 7 out of 16. Then it goes down, 16 goes to 15, and out of 7, there are 6 left. So this is 7 out of 16, 6 out of 15, 5 over 14, and all the way to the end. That gives you the same answer. What if a sample of 7 sprockets is selected? Find the probability that none are defective. In other words, if you go here, the denominator remains the same. This one is 7, 0. This one is 9, 7. So probability of non-defective is n of non-defective over n of s. N of s is the same n of s. Okay, and the numerator, as I said, that's why when you, let me erase my work. When you write it in this fashion, it makes it easy to understand what's happening here. From 7, we choose nothing. From 9, we choose all the 7. That's it. And of course, this one is 1, so do the rest. And 9, 7 is 36. The other one, we already have the same answer. The ratio and the simplification gives us 9 over 2860. Now, the second method is that the very first step, remember what we want, is selected the value that none is defective. So the very first one is 9 out of 16. And then it goes down, 8 out of 15, so on and so forth. And the final answer is 9 over 2860.